Welcome back, class. Thank you for joining me for our 8.5 notes. Today we are going to continue our conversation on factoring. However, we are going to be factoring things a little bit unlike what you've seen before. We're going to factor trinomials of the form x squared plus bx plus c. So essentially what that means, by the end of notes today, if I give you something like this, you will be able to factor it. That is the form we are talking about. Now, before we dive into that, I'd like to have a little conversation about foiling. So, in the foiling process, let's take a look at what's happening. Remember, foiling being two binomials. Now, the first term, x times x, gives us our squared term. Now, the majority of the things we are going to be dealing with today are square terms. So we're really talking about quadratics, all right? Now, I want you to notice the outside and inside. What do they end up doing? Well, they end up adding together to give us our x term. And finally, our last for the L, they multiply to give us that 21. So a couple of things I want to point out today. So first of all, the coefficient of the x squared. The coefficient of that x squared term, well, when it's not showing, remember, it's just 1. Now, that is important because today, notice, our factored forms are all going to be that way. We're going to start with this very nice simplistic case where the coefficient of that x squared term is going to be 1. Now, it's important when the coefficient is 1. Let's look at the relationship between the 10 and the 21. So, where is this 10 coming from? Well, when we look at what we're factoring, the 10 comes from the 3 and the 7 being added together. 3 plus 7 is going to give us that B term, that 10. And where's that 21 coming from, that C term? Well, if you look at that same 3 and 7, 3 times 7 is giving us that 21. So, if you look down below, notice that the numbers, which when multiplied, they equal the C term, that constant, so that's our C, and add up to the B term being the one with the X. And again, this is a very nice case only when that coefficient of the x squared term is 1. So, now we're going to discuss the reverse of the following process. The reverse of the following process is factoring these quadratics. So today we are going to focus on factoring things that look like this. X squared plus 10x plus 21. Now factoring. When we factor a quadratic such as this, we are always looking to go back to those two parentheses, okay? So that's always our goal here. Factoring goes back and creates multiplication. Now, these two terms here, remember this x squared was created by those two terms. That is why it's really easy when you just have an x squared there. Because what two things multiply to give you x squared? Well, x and x. So that's why this is a very nice case. When all you have is x squared, you know the only way that's happening is x times x. And that 21 is coming from those two numbers of the foiling process. All right, so, and specifically that last number is created by multiplying that. So the way I always start these problems is I start brainstorming. I break down that 21 into the things that multiply to create it. So what could be 21? Well, 1 times 21 can give you 21. And 3 times 7 could give you 21. All right, well, and those are actually the only two things that multiply to give you 21. Now, don't forget we have another restriction. We have that 10 because this and this add to give us that 10. We saw that in the foiling process. So once I've created my list over here of things that multiply to give me 21, now I have to shift my thought into what also adds to give me 10. And this is obviously the example we started with, so hopefully you guys can see already that it's coming from the 3 and the 7. 3 times 7 will give us that 21, and 3 plus 7 will give us that 10. So that is how you are going to factor these. Right? We're going to reconstruct what we had before we would have foiled it. So again, to recap for this next page, to factor a trinomial in the form of x squared plus bx plus c, you must find two numbers that have a sum of b. They have to add to that x term and a product of c. They have to multiply to your constant term. So, what is a factored form of x squared plus 8x plus 15? And again, when I'm asking you to factor this quadratic, we're going back to our parentheses. This x squared term, again, came from those two being multiplied, our first terms being multiplied. And again, that's why I love this form so much. Two things that multiply to give you x squared. Well, we know the only way that that is going to happen is x times x. Now we let things get a little bit more interesting. Now we know that this 15 came from this and this being multiplied. So this is where, again, I'm going to start brainstorming things that multiply to give me 15. Well, I know 1 times 15 does, and I know 3 times 5 does. And again, those are the only two things that this actually happens with. So that's all we have to brainstorm. Now we're going to shift gears because we know that that middle term, that x term, is also coming from adding this and this. So now that we've created our list of things that multiply to 15, let's hone in on that list and see what also is going to add to give us 8. And I'm hoping that you can see 3 plus 5. That is going to give us the 8 we're looking for. So we have a positive 3 and a positive 5. So when we factor this, we're going to get x plus 3 and x plus 5. Now, how can we check our work? How can we see? What if I doubt whether or not I'm right? I'm not sure. Well, the cool thing is there's a really easy check for this. You can actually FOIL it back out. Once you have what you believe to be the answer, you can FOIL it and check. So let me show you really quickly. F for first. X times x gives us x squared. O for outside. X times 5 gives us 5x. I for inside. 3 times x gives us 3x. L for last. 3 times 5 gives us 15. I can combine my like terms together to give me 8x. And look at that. You get back exactly what you started with. So that x plus 3, x plus 5 really is the factored form of this quadratic. So let's do another one. What is the factored form of r squared plus 11r plus 24? I'm asking you to factor a quadratic. Now, don't be concerned that the variable is different. Even if you have a different variable, it's going to act exactly the same way as when you had an x. This r squared is still coming from the first terms. So what two things multiply to give you r squared? Well, that's the same question as the two things to multiply to give you x squared, except this time it's going to be r and r. These two terms here, those are coming from 24. two things that multiply to give you 24. So now 24 is actually where we get to have a little bit more fun brainstorming our list. Things that multiply to give us 24. 1 and 24. How about 2 and 12? 3 and 8. 4 and 6. All right, so this time our list is a little bit more fun. We're getting more things here. So looking at this, now I need to shift my gears because again, we already know this times this also have to add to give me that middle term, that 11. So we need to look at our list. We need to look to see what is also going to add to give us 11. So looking at this list, 1 plus 24, nope. 2 plus 12, nope. 3 plus 8, oh, there we go. So 3 times 8 is giving us the 24 that we need. 3 plus 8 is giving us the 11 that we need. So I'm going to fill this in with positive 3 and positive 8. Looking at our next one. So this one is a little bit different. X squared minus 11x plus 24. So the sign of C, well, that 24 is positive. But now I want you to notice, we've shifted gears a little bit. That B term, the term with the X, this time it's negative. So let's think about this for a moment, shall we? So when I'm breaking this down, if I'm being asked to factor it, I'm getting my two things. These first two create that x squared. And again, the only two things that multiply to give us x squared, x and x. Now, we also know that these are coming from the 24. Now, we've already gotten our list for 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. But this time we have a little bit of a twist because when we look at these two numbers, how in the world can they add to negative 11? If we have all positive numbers, how are they going to add to negative 11? This is where we need to remember something very, very critical, all right? There are two ways for things to multiply to be a positive number. So I'm going to go back to this 24 here, okay? Because the only way for numbers to add to be negative, you need at least a negative number in there. Now, when multiplying though, we're looking for things that multiply to give us positive 24. And I've listed all positive numbers. However, there is another way, all right? So I want you to remember two negative numbers can also multiply and be positive. All right, so when you have this case where your C is positive, your numbers are multiplying to be negative, but your, or are multiplying to be positive, I apologize, but your B is negative. They're adding to be negative. The only way that that is possible is having two negative numbers because the two negative numbers will multiply to be positive, but then they'll turn around and they'll still add to be negative. So we're still getting the same 2, 3, and 8 give us 11, but notice this time we need it to be negative 11. So both the 3 and the 8 are going to be negative because they're still multiplying to be positive, but that is the only way that they're going to add to give us the negative that we're looking for. And don't worry, we will do plenty of practice with that to get a handle of it, but that is what we're looking at right now. All right. Next page. So, factored form of y squared minus 6y plus 8. So looking at that, again, for A, factored form, we're always looking for our two parentheses. All right, now, y squared. That is coming from these two terms. Again, nice case. We know we're looking for y times y to give us that y squared. We know that these are going to give us the 8. So let's start brainstorming. Things that multiply to 8. Well, I'm going to start with our 1, just so I am consistent. So 1 times 8, 2 times 4. And now these also have to add to give us that -6. Now here's that case again. My numbers are multiplying to be positive, adding to be negative. So the only way that this is happening, I now know in order for these to add to be negative, I know I'm talking about two negative numbers. That is how I can still multiply to be positive. All right, and now which of these add to -6? Well, the -2 and the -4. All right. Now for B, let's try to break B down. So we have those two parentheses. Again, these two are going to create our x squared term. So x times x will give us that x squared. These two have to multiply to give us that 2. So let's start thinking things that multiply to give me 2. Well, really, it's just 1 and 2. It's the only way. But I also notice I have to add to give me a negative number. So I know that those both have to be negative. Now, -1 and -2, those are the only two options that we have here. And notice that those do not add up to the -1 that we need. So for part B, it actually asks you, is it factorable? In this case, it is actually not. Not absolutely everything is factorable. You will run into some things that cannot be factored. Okay, so that's what B is trying to get you to see here. Is sometimes you can get a setup that can't be factored, and it's all right. So just be on the lookout for those unfactorable cases. All right. We just have a couple more examples that I want to look through with you before wrapping this up. So factoring each of these. Again, we're always looking for our parentheses. The x squared is coming from these two. So x times x is going to give us that x squared. That's the beauty of today. That's always the same. We also need these two to multiply to give us that 24. So I'm going to make my list. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Things that are multiplying to give me 24. And they need to add to give me 11. So which of those things in my list add to give me 11? The 3 and the 8. So I know that I'm looking at a +3 and a +8. All right. Number 2. So these first two terms are creating that x squared. So x times x. They're also multiplying these two to give us a 24. So our list is the same. Now, when we look at the adding process, they are adding to give us that -9. So because they're adding to be negative, we know that actually both of these must be negative. That's the only way that that is going to work. So I start running through my list. -1 plus -24, that is not negative 9. Negative 2 plus negative 12, again, not negative 9. Negative 3 plus negative 8 doesn't give me negative 9. Uh-oh, negative 4 plus negative 6 is not negative 9. So in this case, we've exhausted all of our options. Nothing fits that restriction of multiplying to 24 and adding to negative 9. So this is going to be not factorable. It's another one of those cases that is simply not possible. All right, and our next one. Factoring means we want our two parentheses. These first two terms are giving us that x squared term. So x times x. Next, these two are going to multiply to give us our 12. So we're looking at 1 times 12, 2 times 6, 3 times 4. And we're looking for those same two to add to give us 7. So looking at our list, we're looking for something that adds to 7, the 3 and the 4. So positive 3, positive 4, and there is our answer. Now, I think I'm going to cut it off here. We'll start class by wrapping up with that 4, 5, and 6. So thank you so much for joining me for this notes video. Make sure you have all of these filled out. We will start class with the remainder of these tomorrow.